Hello everyone. For today, I have solved 4 questions of linked list. 2 of them are the extensions of tortoise and hare algorithm. So in this journey, our first question is length of loop in a linked list. So basically in this question, we have to detect the length of the loop that exists in our linked list. So for the brute force, I have used the concept of hashing, where I use the map and store the node with a value or a timer, and we put all the nodes in our map, and after detecting a loop, we counts we count the timer, and in this process we go from one node to another node, and eventually we come back at the same node that has been encountered earlier. That's how we can detect the length, and after that we subtract the total current timer minus the timer that has been encountered earlier, and that's how we can calculate the length of the loop. And for the better approach, we can use the tortoise and hare algorithm. In this algorithm, we use the concept of slow and fast pointer, and by this we firstly detect the loop and then maintain a counterpoint. And counter, we simply counts the loop, we counts the number one by one, and that's how if we again cross the same node, we count all over the loop. That's how we can calculate the length of our linked list. So that's the first problem. The second problem was delete the middle node of a linked list. So it is also an extension of tortoise and hare algorithm. So we have earlier detect the middle point of the node, and in this question we have to delete that. So there will be two cases. One is for the odd length and one is for the even length. For the odd length, we have the centered node as the middle node, while the even length we have two middle, M1 and M2. So in this question, we have to delete the M2 node. So by analyzing this question, our main target should be to reach to the node that's way before to the middle node, so that we can adjust the nodes connection and free up the node that's the middle. So in this question, I use the concept of slow and fast pointer, but there is a way. Uh, if we use slow and fast pointer in like we found in the middle of the node, so we will eventually go to the middle of the node. But our target is to come on way back node. That's just before the middle of our node. So for this, we will firstly uh, extend our fast node one steps ahead, and after that our loop will start for time that's not equals to null. So that's how we will solve this problem. And another problem is delete all the occurrences of key in a doubly linked list. So in this there is a question where we have multiple element, and some of elements are occurring again and again, and we have to delete the occurrence of that element, and that is given as the key. Like we have given key as 10, and in our example there are multiple 10s and we have to delete all the 10 nodes. So for this we will traverse, and it's the doubly linked list, so we can traverse front and back also. So in this we will traverse while temp not equal to null, and if our first node is the 10th node, so that's the head, so we have to switch our head to the next node. Or if it comes before the node, so we will make connection. We will connect our node by using 3 pointers: previous, current and next pointer. So using them we can simply connect each other nodes, and this is the process while solving this question. I suppose that I am not able to explain it much better, because it is very simple question, and in this question we have just to attach the nodes link, and if there is a 10 encountered, we have to simply delete that node. So it does not have any concept, it's just linking of nodes. After this, the last question that I solved is find all pairs with given sum. So this is somehow tricky question. So in this question, we have multiple nodes and we have given us some value. And if any of two nodes added and they got the value as our sum, so we have to return that pair. So we have to return all the pairs that are possible to make that sum. So for the brute force, let me example. So for the brute force, yes, we have used the two pointers where we have a temp1 and a temp2. So temp2 is way ahead from temp1 and they both eventually move together and it's like a bubble shot. So our one pointer stays on the head and other pointer travels all over the node up to the tail and added the number, and if their sum is getting to our value that is given, so we add that to our data structure that we will take, and this is how we increase our elements. So our one temp will be at head and another temp will traverse all over the tail, and after traversing all over the tail, our first temp moves to the next node, and again that process continues, and that's how we solve this problem. So for this problem, if we solve this problem like this, our complexity reaches to the big O of n square. So for better approach, we will use the concept that is very famous. So we will take the pointers, but one pointer will be at the head, while the another pointer will be at the tail of the linked list, and simply add those number. If the number is equal to our key, we will return that pair, and if the number is greater than our key, so simply our tail element will be decreased to its previous element, and if the number is less than the sum, then we have to increase our left element, that's temp1, to its next node, because in this question the linked list is sorted. So that's how we can solve the problem, and by using this our complexity reaches to big O of 2n. So that's how I solved that problem, and that's enough for today, and we will continue our journey, and I will meet to you in my next video. Thanks.